the next 10 or 15 minutes, we shall be looking at hoses, and in particular at safety aspects of using hoses under high pressure. Of course, we all know what a hose is, or do we? The dictionary says that it is a flexible pipe for conveying water. Well, that defines it, in rather a limited way. But describing a hose is quite another matter. Take a simple example. The ordinary garden hose is very different from, say, one used for firefighting. Each is designed for a particular purpose and would not do the other's job satisfactorily. In industry, hoses are used very extensively. They carry not only water, and indeed not only liquids. So let us begin by redefining them as flexible pipes for conveying fluids. That covers liquids, gases, and even some free-flowing solids. Each must be equipped with end fittings appropriate to the job to be done. If the hose is being used under high pressure, attention to safety is extremely important. It is very much in the user's interest to treat hoses with due care and to report any defects seen. Here, cylinders are being filled with carbon dioxide. This is an important aspect of the business, and thousands are filled each week. The cylinder filling pump draws liquid CO2 from the storage vessel and delivers it to the filling point at a pressure of about 80 bar, 1,200 pounds per square inch. The flow of liquid is controlled by a solenoid valve which opens as the operator presses the button and closes when a pre-selected weight is reached. The hose used is made of nylon reinforced by a braiding of stainless steel wire, which is in turn covered with a smooth plastic sleeve. It is designed to withstand a pressure greatly in excess of that delivered by the pump. It is permanently fixed at one end, and the length is selected to enable it to be used for cylinders of different heights. It is fitted with a spoke nut, which can be tightened onto a specially designed sealing washer without the use of tools. This nut has a built-in safety retainer. The unit is designed in such a way that the thread can only be engaged when the retaining ring has been put in position over the cylinder valve. Factory safety rules require hoses of this type to be inspected at regular intervals by a member of the maintenance staff. The defect most commonly found is wear on the thread of the nut, which is checked by means of a gauge. Any defect or suspect item is immediately replaced. However good the condition of the hose may be, the effectiveness of the connections depends equally upon there being satisfactory thread on the cylinder valve. The operator inspects this visually while placing the cylinder in position. The higher the number of times a hose is coupled and uncoupled, the greater is the danger that through wear or through faulty operation there will be some insecurity of a connection. Safety procedures should be aimed firstly at preventing this, and secondly at minimizing the consequences should it occur. Let us look at some examples. If the nut fails, some leakage occurs, but the hose is held safely by the retaining ring, enabling the operator to stop the flow without risk. If the hose discharges without a cylinder in place, a further safety feature is provided. A fixed eye or chain restricts the whipping tendency of the hose to only part of its length. How necessary is all this? This demonstration of what happens when the hose is completely unrestrained provides its own answer to that question. Now let us take a look at the bigger end of the business. Here, a driver is about to load his tanker from a factory storage vessel. If possible, the driver positions the back of the tanker less than 12 feet from the loading point, since this is the length of each hose. The vehicle does, however, carry two pairs of hoses, which may be coupled together to make it possible to operate at a greater distance if necessary. In order to gain access to the connections on his tanker, the driver must move the bar which covers them. This actuates a valve which exhausts the air from the vehicle's braking system, making it impossible for him to drive away until he has uncoupled the hoses and replaced the bar, thereby closing the valve. In bulk transfer operation, two hoses are used. The smaller one, which is of 1 inch diameter, connects the tops of two vessels to ensure that the gas pressure, about 20 bar, is equalized and remains so as the liquid is transferred by the pump through the larger 1.5 inch hose, which connects the two tanks at the bottom. Unlike cylinder filling, where one end of the hose is permanently secured, tanker operations require the driver to couple and uncouple both ends of each hose on every occasion. Consequently, there are 4 connections. Each of these presents a potential hazard. Failure to tighten properly a faulty thread, a nut damage to the point of fracture by careless handling, a defective wire whipping or swaging securing a tailpiece, any of these could result in a hose breaking free. Such incidents are rare but not unknown. The driver therefore secures each connection by means of a nylon lanyard to hold the hose if this should happen. These lanyards were the final outcome of a long series of trials to find the most suitable restraint for tanker hoses. They have been used for many years, and in that time have prevented a number of accidents. The makeup of these hoses consists of 6 parts. Around an inner stainless steel coil are wrapped woven Tyrolean fabric, Melinex, which is a plastic material, woven Tyrolean again, and butyl-coated cotton fabric, which offers a high resistance to abrasion. Finally, all are surrounded by a second stainless steel coil. The end connections consist of brass hexagon nuts attached to a tailpiece, which are secured into the hose with high tensile whipping wire or swaging. The hoses are regularly inspected and are removed from service if there is any sign of defect. Having completed the bulk transfer operation, the driver closes the liquid and gas balance valves. He then vents the hoses. Purging should be from the lower end of the hose to minimize gassing off and the consequent formation of an ice plug inside the hose. The driver leaves the lanyards in position until after he has undone the nuts, so that he is protected against any sudden movement of the hose if for some reason there should be any residual pressure. Finally, he removes the lanyards, places the hoses in their carriers, closes the safety braking valve and the pumping compartment door. It should be noted that the whole operation is carried out by one man, thus avoiding any possibility of hazard arising through misunderstandings. Let us now see how the safety device works if called upon. The hose kicks but is able to move only slightly because it is securely held. Now let us see what is the effect if the hose is not restrained in any way. The white fog effect caused by the liquid CO2 makes it difficult to see clearly what happens to the hose. So let's repeat that using only gas pressure. This demonstration was staged in such a way as to ensure that it would do no harm. It is not difficult to imagine what could happen in the real-life situation, and to see that it is important to do everything possible to prevent it. In conclusion, let us sum up the safety points that arise from all this. The company, in consultation with the hose manufacturer, must select and supply the right type of hose for the job. Careful handling to avoid accidental damage is essential. Regular inspection is necessary because no matter how careful a hose is used, some wear is inevitable. Defects noticed during operation must be reported. The operator must ensure that all connections are properly made and tightened. Appropriate safety devices must be supplied and used. Finally, no one, operator or driver, maintenance fitter or manager should ever underestimate the danger that can arise from failure to observe these precautions. Properly used, a pressure hose is an essential tool of the trade. Out of control, it is a menace to life and limb.